Hi everyone, welcome to MacMod.io. My name's Johnny Mac and I'm a software professional and host of this channel. Happy St. Patrick's Day 2025, always an exciting day, one I look forward to as a gateway to springtime. One of the few days a year we have cabbage and corned beef and soda bread here at my house. Thanks for tuning in to check out this video. I'm really excited to share with you today about how to build and run simple Web3 application entirely on your local machine using Hardhat and Viem. Watch all the way through to the end. I'm going to share how to deploy your app contract to a live testnet or mainnet using Hardhat's ignition interface. But first, why would you want to build a Web3 application? What do you stand to gain by doing so? What's Hardhat? What's Viem? I'm not going to go into all the details of Web3 and the architecture principles or do a full breakdown of the value prop right now of blockchain-based apps. I'll have a whole nother video for that. Really quickly, if we think about a traditional web service, you have central services hosted by the company that owns the domain of the web application. All information submitted from the browser is proxied through these services, and information is stored in a database or in additional services. You need to register and log into these apps. Your password is stored in one of the databases owned by that business. Decisions about how to use the data in those databases is highly restricted to people that meet in boardrooms and have legal and financial control over system administrators or the system administrators themselves that have access rights and super passwords, right? The blockchain industry has dubbed this model Web 2, and it recognizes the development of a data persistence layer beyond the original concept of Web 1 static HTML pages that you remember. But over the past few years, the term Web3 has been established as the term really to represent web applications that integrate with the blockchain to facilitate those use cases. And when we look at that model, a pure Web3 application, all of its interactions are made to open blockchain protocols. So in such a model, there's no login and password experience that's specific to the application. Instead, account management is facilitated through a Web3 wallet key. You can think of your wallet key as a sort of single key that grants access to write and approve transactions for your account on these protocols. No one else has the same key as you, or at least we know that there's only a 1 in a trillion chance that someone else has the same key as you, which is like the odds of winning the lottery twice in a row. So chances are very low that someone else has the same key as you. And this has multiple benefits to all the parties involved, but there are two really that are the most important in my opinion. First, it's automation. It's running, right? These protocols and networks are maintained by hundreds, if not thousands, of contributors across the world. And there's no single point of failure in these protocol networks. It's cheap, right? You don't have to set up web services and host them on AWS or on some rack space somewhere. And you don't have to rely on third-party systems to, store data securely. And all of that adds costs, right? If you're building a traditional web application. Furthermore, the transaction history in a blockchain, it's open and transparent. The data is owned by the account holder, not the central service provider. So a system admin can't go into the database and change the data if they're so inclined or if they are instructed or directed to do so by the boardroom. And so these are all the advantages of using this type of architecture. Again, cheaper and more transparent, right? And also the data ownership resides with the actual source of the data, which is the account holder. So then what's Hardhat and what is Viem? Hardhat is a utility that helps developers write, test, and deploy Ethereum-compatible smart contracts. You may remember Truffle, some of you that have done this in the past or experimented in the past. It was a similar utility. It was sunset about a year and a half ago. And Hardhat is very similar. It provides much of the same functionality that Truffle did, including the Hardhat network, which is a full Ethereum-compatible network node that's integrated into the tool and runs right on your local machine. As for Viem, Viem is a Web3 client written in TypeScript. It provides an interface to Ethereum compatible protocols. It has much of the same functionality as Web3.js, Ethers.js, except it has an emphasis on type safety and performance. And we can see here their value prop, why meme, a brief preamble on why we built Viem. I encourage you to go check this out and read it. It breaks down why they've offered this SDK over the use of Web3 or Ethers.js. So now that we've established why we want to integrate a Web3 wallet into our web app and a little about Hardhat and Viem, let's learn the very basics of doing so by building a working application that interfaces with a blockchain protocol, all running on our local machine. First, some prerequisites. I'm going to be using Docker and the VS Code IDE on my Mac. It's probably a good idea to have some understanding of containerization and container runtimes, or you might get a little lost. But most importantly, you should have a passion for blockchain and what makes smart contracts significant and meaningful. I hope that's why you're here, and that's how you're going to get the most out of this video. Now, what's our goal? With one easy step, we want to bootstrap an environment on our local machine. And with this one easy step, we're going to build and run a Hardhat network in a local Docker container that's going to use Viem to write and deploy a simple contract to the network with Hardhat Ignition. It's going to deploy a smart contract for a simple token, and it's going to set up a Web3 front end that interacts with this contract. And what will this do for us? Writing smart contracts and deploying Web3 applications can feel a little overwhelming. If you're like me, there's nothing more relaxing than developing on my local machine where I know I can't do any harm to anyone or anything, and I'm free to experiment. I can iterate on the code and demonstrate how I can rerun the process with zero state preservation and minimal effort to deploy the contract. But you can use the test nets, and that's fine, and you can use the web IDEs to do this work. But I just like working on my local machine. It just gives me a sense of security, and that's always how I've done my work. So let's go ahead and get this set up. Okay, so if we think about how this application is structured, we have our front end component. That's going to be our decentralized app. It's going to be a React Dapp interfacing with our back end, which is our Ethereum node. And we're going to use Hardhat to run that node using the Hardhat network. So let's go ahead and hop in here, and we're going to create a few directories to represent that structure. So first we'll create our Hardhat directory to represent that backend, and then we'll create a Dapp directory to represent that front end. Let's go ahead and hop in here to our Hardhat directory. I'm going to create a Docker file for this component, and we're going to call that dockerfile.hardhat. It's just a very simple Docker file. This is going to inherit from the Node.js base image and create a working directory in the container. We're going to go ahead and do the same thing for our Dapp, create a Docker file for that, and it's just going to be the exact same thing. And finally, we'll create a Docker Compose file to manage these two services. And what we're going to do there is we're just going to create a Hardhat service that references that Docker file we created. We're also going to mount that directory into the container. That way, any changes we make, files we create in the container will be persisted out to the host machine. And we'll do the same thing for the Dapp. Okay. So with that, we ought to be able to build these containers. Great. And we ought to be able to now run them. Excellent. We haven't really done anything too interesting yet. We created two containers with the Node.js base image. That's not too interesting, and we've run them. But let's go ahead and take this to the next step. And we're going to hop over to VS Code to make this a little easier to follow along. Okay, so here you can see that we have the two directories that we created with the two Docker files that we created and the Docker Compose file that we created. So let's go ahead and open a terminal here in VS Code and run these services. And with them running now, we're going to go ahead and shell in to the Hardhat container. And when we're here now, we're going to install some dependencies, right? We want to install Hardhat and we want to install TypeScript. These are the two main dependencies that we need to get our project started. So let's go ahead and do that. We're going to install Hardhat and TypeScript. Okay. And as those install, we're going to see that the modules directory will get created, and we'll also get a project.json created. And here we have it. So now we have these two dependencies installed, and we have our modules. Great. So next thing we're going to do is we're going to use the Hardhat runner to initialize a new project. And the Hardhat runner is accessed through npx hardhat. And we're just going to use the init script that gives us this nice interface, and we can create a TypeScript project with Viem. Excellent. Create that in our root. Git ignore and yes, install the sample project's dependencies. Excellent. And this is going to give us a sample project. This is a nice way to get introduced to what Hardhat expects as far as folder structure. It does provide a few samples as far as a contract and a deploy module go. And that's fine. We're not going to use those for our project, but we can see them here, and it's nice to see so that we have a reference. Okay, and so what we are going to do now is we're going to create a contract. And what I'm doing here is I'm essentially taking the Hardhat boilerplate project, which is a little bit dated, and using it to drive this tutorial. Now, I can't just take that project as is wholesale because it, like I said, it is dated and it doesn't support Hardhat Ignition or TypeScript or Viem. And so we're making some upgrades to it. But if you find that online, it's essentially what we're referencing here to create our Dapp and deploy our contract. And so what we'll do here is we're going to create a new contract, and we're going to call this token.sol. And this is a custom contract that we're going to create. It is not a ERC20 token. I don't recommend deploying this to production. I would recommend using an official ERC20 contract that you can inherit from OpenZeppelin. But for the purposes of this tutorial, we're just going to use this contract. And this contract is fairly straightforward. And if you have some familiarity with Solidity, you should recognize this. If not, you shouldn't be too overwhelmed. It is an object-oriented, type-safe programming language, so it shouldn't be too novel if you've seen anything like that before using Java or Swift or Rust. So here we have our contract. We have a name, a symbol, we initialize a total supply, and we create an owner and a hash map of address to balances. We have a transfer event. We initialize the total supply and the owner and the constructor. We have a transfer function, and also we have a balance check function. Again, this is not an official contract, but it will serve the purpose that we need. So the next thing we're going to do is we're going to create an ignition module, and this is a Hardhat module that we're going to use to deploy the contract. And it's how Hardhat is going to interface with the contract using TypeScript. So when we look at that, it's just going to be token.ts. And this is pretty simple. We're just going to build a module called token module that's going to reference the contract that we created. And finally, we're going to add a test here. And this test is going to ensure that our module and contract are functioning as we expect them to. And again, this is one of the benefits, right, of doing it this way in using Hardhat, is that we're all on our local machine. We can actually write tests that run and execute and deploy a contract over and over without compromising any state in the real world on a testnet or a mainnet, right? And that's a nice feeling, right? You can run these over and you can restore state very quickly. So we'll go ahead and see now if we can run this test. Now, the Hardhat runner does offer that interface. and we should be able to execute npx hardhat test. Okay, great. And all these tests pass. So what we've done here is we tested both the lock and token. The lock was provided with the project boilerplate, and then we added our token contract tests. So ignoring the lock, we have a deployment that should set the right owner, should assign the total supply, verifies that we can transfer and emit events, and that's all here in this test. So you can go ahead and take a look at this. This will be available on my GitHub, and you can see how this works. This uses Viem to test that we can successfully deploy and that we can interface with the contract as we expect. And this is going to set us up now to build our Dapp, because we have tested this interface that we built and deployed, and now our Dapp should work using those same interfaces, right? So using the same SDK, using that Viem SDK. And that's great, right? Because now we can hand this off to a front-end team, or if we are the front-end team, we can go ahead and implement our core application logic with that confidence that this is working. So if something's broken, it's not this, right? Okay. So now let's go ahead, and what we want to do is actually deploy the contract locally. And to do that, what we need to do is run the Hardhat network. And so the way to do that is we're going to npx hardhat node. That's going to launch the network with 20 accounts. So I'm now running an Ethereum node locally with Hardhat, and I can theoretically now write a Dapp that should be able to interface with this node running on my local machine. But before we do that, we want to see if we can deploy the contract. Theoretically, that should work because we just wrote all these tests and they passed. What we're going to do here is open a new terminal. And again, with that service running, right, let's shell back into the Hardhat container, and let's see if we can deploy our contract to that running node. So the way we do that is we're going to use Hardhat ignition. Ignition, deploy, and we are going to reference our token module. Okay, so that is located in ignition modules token.ts. There it is. And we also want to tell Hardhat to use the localhost network. Okay. Excellent. So our contract is deployed now on our local machine, and we've verified we have now a contract address, and that's fantastic. A few other artifacts that we want to know about that were created. The ABI, which is essentially going to be the template that a client like Viem is going to use to know how to interface with the contract. And that's going to get dropped here in the ignition, deployments, artifacts, token module token. And this is maybe a little bit of a confusing file naming convention, but essentially what they're doing here is, you know, it's the module and then the contract. So theoretically you could have multiple contracts in the same module. This got a little tricky for me because you can't really import a file with this hashtag in the file name. And so that'll come up here in a minute. But this is the ABI for our contract. And then we have the deployed addresses so that we know, okay, we have now file created, a JSON file created with our contract address on the network. And that is the same here. You can see that the network reported. So that is where we're at this point. We have now the contract deployed, and we have a contract address for it, and we have an ABI for it. Okay, so the next thing that we're going to do is, now that we have the contract deployed and we know that we can run the Hardhat network, let's go ahead and simplify, because remember, our goal is to have that single command that kind of bootstraps this whole situation. And so what we can do is we can now enhance our Docker Compose file and add a command there so that when we start the services, we actually launch the network. And so we're going to go ahead and exit out of this container shell, and we can kill off this terminal. And similarly, we're going to exit out of this shell and this as well. And let's go ahead and shut this thing down. Now, when we come back to our Docker Compose file, what we're going to do is we're going to add a service, a command, excuse me, to run npx hardhat node when we start the container. And so let's go ahead and see if that works. Okay, excellent. So now we have this one command, Docker Compose up, that starts our container. It has Hardhat and TypeScript installed, and we go ahead and run npx hardhat node. Now, because the container is ephemeral, what we did previously in deploying the contract needs to be done again. So that is one caveat. We do need to redeploy the contract. There's a way that we can set things up so that happens on Docker Compose up, but in this tutorial, we're just going to go ahead and open a new terminal each time we restart the suite of services and shell in to the Hardhat node and redeploy our contract. I think this is okay. In addition to ensuring that our state is reset, it's also good to practice and get accustomed and get this committed to memory, that this is how we deploy contracts with Hardhat Ignition. So again, we're going to reference our contracts here. Excuse me, our module. And we're going to go ahead and specify the network as the local host. Okay, excellent. And you can see that the contract address is actually the same. This is a likely outcome, a highly probable outcome. So we can be confident that for the sake of this setup and testing, again, this is for development and testing, this setup to use the Hardhat network on your local machine. We are confident that address is going to be consistently the same. Okay, so now we have this one command. The next thing we want to do is start our Dapp. So let's go ahead and get that started. So if we think about how our Dapp is going to be structured, we talked earlier about using React to interface with our Ethereum node. Again, we're following along with that Hardhat boilerplate project, which uses this model. And so let's go ahead and get that set up. So we're going to run a new terminal here, and we're going to shell into the Dapp container. And let's go ahead and install some dependencies. We're going to install React and the React DOM. Let's go ahead and install Viem. And let's get Bootstrap for some styling. And this should, again, because we mounted that volume, we're going to see those files persisted to our host machine. Okay, great. So now we have our package JSON. And we're going to need to install some dev dependencies as well. Let's go ahead and install TypeScript. And we're going to use Byte for this project. And we have some scoped modules for React and React DOM, as well as a Byte.js plugin for React. And we're going to save those as the dependencies. Okay, great. And so now we have these dependencies installed. So what we can do is we can actually enhance now our Docker Compose file to ensure that these dependencies always get installed when we start the container. And so what we can do is go ahead back to our Docker Compose, and we can add a command similar to the way that we did for our Hardhat service down here in our Dapp service. And for this though, instead we're going to run npm install. Okay, and so now we should be able to theoretically exit out of this shell, and we don't need this terminal anymore. And if we actually exit out of this shell as well, which is where we launched our contract, right? And come back to our shell here that is running the Docker Compose up. If we restart this now, what we should see is now what we're going to do is bootstrap the Hardhat network and our Dapp with our dependencies installed. Okay, great. And so that's what we have done here. Again, that Hardhat network is now reset. So we do need to go ahead and launch again, shell into our Hardhat network, and redeploy our contract. Okay, excellent. And so now we have a Dapp that is running and it has dependencies installed in the container, and we also have a contract that's deployed. But we don't actually have a Dapp, right? We just have a container with dependencies installed. So let's go ahead and start working on this Dapp. What are we going to build? So we come into the Dapp directory, and let's start with our index.tsx. And in this file, what we're going to do is we're going to go ahead and start the process, and we're going to import the React DOM, and we're going to go ahead and import Bootstrap, and we're going to go ahead and create our root element. And what we also want to do is import our Dapp, the component that we just referenced, which doesn't exist yet, and that's fine. Okay, and the next thing we want to do is we want to create our index.html, and this is going to ensure that we load our TSX module. Okay, and we see here this script is going to load our TSX module. Okay, and now we want to create that components directory, and in there we're going to create our Dapp. And in our Dapp, we're going to start to get some code here that looks a little more interesting. So what happens here? That should be. So first we're going to import the React component. And then we're going to import some of the functions that we need from Viem, as well as Hardhat from Viem chains. Okay, and next what we want to do is we want to define window.etherum. This is important for Metamask. Some constants. Now this is important. This is the actual URL and port that our Ethereum node is running on. So when we launch the Hardhat network, it's going to expose a JSON RPC interface that we can then talk to, right? And we're going to use Viem to talk to that interface, and this is where we specify the URL that interface is running. We also give it the default Hardhat network ID, as well as an error code for a rejected user. Okay, and then we're going to go ahead next, and as I mentioned earlier, we want to be able to configure Viem with the ABI that we generated when we deployed our contract. And so we need to reference that. And currently it is in our Hardhat container. So the next step we're going to take is we're going to go ahead and copy that ABI from our Hardhat container into our Dapp container so that we can reference it in the Dapp. And the way that works is we use Docker copy. And so we come here to the terminal and we're going to go ahead and we want to do this using Docker copy from our host machine. Our host machine is going to be able to see into both the Hardhat and Dapp containers and copy files from one or the other. Now remember, we mounted, and we can use that same principle if we want to. However, due to the file naming convention having the hashtag, it's not great to just mount the volume that we created, the directory that we created in the Hardhat container for our ABI, because we're not going to be able to import it anyway because it has this hashtag. So it's a better experience and it's more consistent with a real-world experience where the ABI is going to be hosted somewhere, not on the network itself. And so this is more in line with what you're going to do if you're building a Dapp in production. So we're going to go ahead and copy that ABI, and then we're going to fetch it in the same manner that we would if it was hosted on, some service provider somewhere or IPFS. So for this, what we're going to do is we're going to create a directory in our Dapp called public. And this is going to allow Vite to serve the files by default. Anything that you put in the public directory, Vite will serve by default. So let's go ahead and create that in our Dapp. Now we're going to go ahead and copy the files from our running Hardhat node container into the Dapp public directory, which, as you recall, is mounted and so therefore should be accessible inside the container running the Dapp. So we can get the ID of our running container here for the Hardhat node, and then we can Docker copy from there. And we're going to go ahead and copy from the app ignition deployments chain artifacts to our Dapp public token module. And you see how we're changing the file name here. We're removing that hashtag, placing it with an underscore, and that's going to make it much easier to import into our Dapp. Okay, and then we also want to copy over the deployed addresses. And so these are located here in deployments, and it's just going to be the deployed addresses.json 31.237 deployed addresses.json, and we're just going to copy that over to our Dapp public deployed addresses.json. Okay, and so we see now over here we have a public directory with these two JSON files. One is our ABI, and the other is just a list of the deployed addresses. For the contracts we deployed, we only deployed one, which was the token contract, and this is the address of that contract. Okay, great. So now back to our Dapp, we can now import these files to our project. And what that looks like is this. So we're going to go ahead and async function load ABI and async function load addresses. Okay, so the next thing I'm going to do is I'm going to go ahead and skip ahead here. This code will all be available on the GitHub repo in the description below. But just to save time, and again, this is mostly lifted from the boilerplate project and with the modifications for Viem. The rest of this Dapp looks like this. And now there are multiple references in here. that we're going to have to create as components. So we have the connect wallet, and that looks something like this. Okay. We also have a loading component, and that looks like this. Okay. We also have a network error message and a few others. I'm going to go ahead and skip to the end of this part for you. Okay, so you can see what we've done here. We have added these components and now we've imported them into our Dapp. And this will all be on GitHub, so you can go ahead and look through these files. We've also added a configuration for Vite for React, and we've also added a TypeScript config. The other important thing we've done here is we've enhanced our Docker Compose YAML file. So we will start the Vite server for our Dapp after we run npm install. And we're also going to expose the port that the Vite server is running on to our host machine so that we can access it through our browser. We've done the same thing for the Hardhat network because we want to make sure that the Dapp that's running on our local machine can also access the JSON RPC server that's running in that container on port 8545 as we configured it here in our Dapp. With those configurations, we are now set to go ahead and spin this up. Okay, great. So now we've gone ahead and started the services, and with our commands, we are now running the Ethereum node with the Hardhat network, and we are running the Vite server that's going to serve our Dapp. And we got to remember then to always come into the Hardhat container, and we're going to go ahead and rerun our contract deployment. Okay, great. So we have our contract deployed. We're running our Ethereum node, and we ought to be able to come here and see that we can connect to the Dapp, and now it's asking us to connect our wallet. Great. So here we are. We're going to go ahead and connect the wallet, and we see our Metamask pop up. Now what you want to make sure that you do is you want to configure Metamask to know about your local host. And so the way that's done here is in Metamask or any wallet that you have, you can go ahead and configure your networks, and you're going to add a custom network if you don't have one for localhost port 8545. If you don't do this, then Metamask won't know about it and you'll get errors in your browser console. So we've already done that here. But you can see when we rejected the request, the app is now handling that with a graceful message. So that's good. And we can start this process over. Great, and now we can go ahead and connect. And there you have it. We are now connected to the contract. We're reading the address for our current user account off the contract. We see we have 0 MMT. And now we can go ahead and see that there's some guidance here that if we want to get some tokens, we can use the faucet. So let's go ahead and take that next step. We're going to create the faucet in our Hardhat project. So coming back over here to our code, what we're going to do is in our Hardhat project, we're going to create a folder called tasks, and we're going to create a file called faucet.ts, and that's going to look like this. Okay, so I'll spare you all the details of this, but essentially what we're doing is we're going to transfer some tokens from the contract to the address that we specify when we invoke the faucet interface. Okay, and so what we need to do then is we need to ensure that Hardhat is aware of this faucet task, and so we can import it here in our config. And now we're just going to reset everything here and relaunch so that we make sure that task is available. And again, we're going to just make sure that our contract is deployed Okay, great. And now we should be able to run the command here that was recommended. And if we come back over here, we can see that this is the command that we want to run. Okay, let's give that a shot. Excellent. So we transferred 100 MMT tokens to this address and 1 ETH to this address. And now we see, voila, we now have 100 MMT and we have this interface now if we want to transfer them. Okay, great. So let's try that out. If we decide that we want to transfer over to another address. Okay, so if we come over to another wallet, we can see here that this wallet has 0 tokens, and we're going to see if we can transfer that wallet some tokens. So we are going to take the address from that wallet and see if we can't send them some tokens. Let's send them 10 tokens and see. All right, oh great. So we have this pop up here. It's asking us if we want to transfer. Okay, cool, we're going to confirm that. And now you see our balance went down, excellent. And if we come back over to that wallet address here, we can see that now it has 10 of the tokens. And this is really exciting. It might be a trivial application. It might not be a production application. But what we've done here now is we have an opportunity to develop locally and we can iterate quickly, right? So we have a setup where we can launch containers, where we're running an Ethereum node, we're running a Dapp, and we can interface with our wallet to communicate with the contract that we deployed. And we can now show that we can transfer tokens between 2 accounts, which is actual utility, right? And that's what's so exciting about this technology, is that it enables these types of user experiences. And to do something like this with your traditional Web 2, you're going to be building out services and creating database tables and trying to track user account balances. And that's fine, and that's a way to do it. But that's all centralized, and you have to build all that, or you have to set all that up. And so this is now using blockchain technology. This is going to be a nice way for anyone to develop an application that's decentralized that can leverage these features of that infrastructure. So we're going to go ahead now and see if we can deploy this contract to a live testnet, and we're going to see if we can deploy to the Fuji testnet, which is the Avalanche testnet. And to do so, we need to specify our private key so that our transaction gets properly encrypted, and the network can then associate it with our account. And so we need to figure out how are we going to store and then read the private key so that we are including it in our request. So let's go ahead and come over here. And to do this, we're going to use just .m for this tutorial. What you want to do in a production type situation is you're going to want to encrypt any sort of really sensitive information and then decrypt it at runtime. You're not going to want to use this method to deploy and store sensitive private keys. But for the purpose of this tutorial, we'll go ahead and use .m. First thing we're going to do is we're going to come into our Hardhat container and we're going to just install .m and save that as a dev dependency. Okay, great. And then we're going to just create a .m file here. Okay. And then we're going to create a environment variable called wallet key. I'm just going to leave that blank for now. And I will populate that in a minute when you aren't looking. Okay, so I'll then configure Hardhat to load .m and the configuration. And then we'll go ahead and configure a network. So this is done with this syntax here. we're gonna set up the Avalanche testnet here, which looks something like this. Okay, great. What we're doing here is we're referencing our wallet key as an environment variable, which is going to be read by .env. And so this should allow us to read that value. And then if we then try to deploy using Ignition and then just specify the network as the key that we used here, Avalanche testnet, then this should deploy to the testnet. Okay. And so as promised, I'm going to go ahead and write this wallet key here. You can't see it. Okay, great. And now when we come back over here, we should be able to, we're going to have to exit out of this and restart because the configuration is only read at the start time. And now when we document those up, okay, we see great. And so now when we come in to this shell, we should be able to now deploy instead to the Avalanche testnet. Let's give it a shot, shall we? Confirm deploy to network Avalanche testnet. Let's see. Great. Successfully deployed, and we have the token address here. Let's see if we can't locate that on Snowtrace, and sure enough it's there. When we come in here, we see there's our token, our MNT. Okay, here's the contract we just deployed, and pretty cool, huh? So that's it for this video. Thanks for tuning in today to learn how to set up a simple Web3 application running on your local machine using Hardhat and Viem. If you like what you saw, please go ahead, tap that like icon. It would really help me out and give others a chance to see this content. Also, do you have any thoughts or questions? Please go ahead and share in the comment section. You want to see more on this topic, other topics? I'd love to hear from you. I hope you're having a great day, and remember, don't stop experimenting, challenging assumptions, and seeking the objective truth. My name is Johnny Mac. This is MacMind.io.